Hi, welcome to class. My name is Don Lafond, Professor Don, and this week in Cisco 2, we are covering our last module, Module 17, Build a Small Network. Presentation takes just about an hour. If you have any questions and you're with me live, please ask your questions after the presentation. I'll leave a question and answer period. If you're watching this as a recording inside of NetAcad, please ask your questions inside of our help discussion forums. If you're watching this on YouTube, please ask your questions down below in the comments, and I'll do my best to answer those questions. And but feel free to go ahead and help each other as well. I'm getting my presentation ready to go, and there it is, ready to go. Module 17, build a small network. So in this presentation, we're going to implement a network design for a small network to include a router, a switch, and end devices. We're going to identify the devices used in a small network. We're going to identify the protocols and applications used in a small network. We're going to explain how small network serves as the basis for larger networks. We're going to scale or talk about scaling networks. We're going to verify connectivity. We're going to use the output of the ping and tracecert commands to verify connectivity and establish relative network performance. We're going to use host and iOS commands to acquire information about the devices in a network. We're going to describe the common network troubleshooting methodologies, and we'll finish with troubleshooting a couple examples of problems inside of networks. All right, devices in a small network. So the majority of businesses are small business networks, consisting of a couple routers, a couple switches, and a few host devices. A small network usually is simple, very simple, and a small network typically has a single WAN connection out to your ISP, whether it be a DSL, cable, or Ethernet connection. Larger networks require an IT department to maintain, secure, and troubleshoot networking devices and to protect organizational data. Small networks are managed by local IT technicians or by a contracted professional. Like large networks, small networks require planning and design to meet user requirements. Planning ensures that all of the requirements, cost factors, and deployment options are given due consideration. One of the first design considerations is the type of intermediary devices to use to support the network. When you're making your choices for routers and switches and other devices like firewalls, you have to take into consideration cost, speed, and types of ports and interfaces, expandability, and operating system features and services. IP addressing for a small network. When implementing a network, you need to create an IP addressing scheme and use it. All hosts and devices within an internetwork must have a unique address. Devices that will factor into IP addressing schemes include the following: the number of end users, number and type of end users, what type of connections they are, wired, wireless, etc., servers and peripheral devices like printers and security cameras, intermediary devices, including switches, access points, routers, if you have any routers that are below the edge router. It is recommended that you plan, document, and maintain an IP addressing scheme based on device type. The use of a planned IP addressing scheme makes it easier for you to identify a type of device and troubleshoot problems that you might run into in the future. If it's documented, it'll be easier to work with. Redundancy. In order to maintain a high degree of reliability, redundancy is required in the network design. Redundancy helps you eliminate a single point of failure. For example, we have redundant servers here. In case one server goes down, the other two servers can pick up the slack. Each of these servers can be running multiple tasks. So it could be an email server, it can be an authentication server. So they can run multiple tasks. When any one is down, the other two are able to continue to work. Here we have redundant switches that are present in case of a switch failure, and we can have redundant routers as well in case a router or a route goes down. Redundancy can be accomplished by installing duplicate equipment. It can also be accomplished by supplying duplicate network links for a critical area. Traffic management. The goal for a good network design is to enhance the productivity of the employees and minimize network downtime. The router and switches in a small network should be configured to support real-time traffic, such as voice and video, in an appropriate manner relative to other data traffic, such as web surfing and file transfer. A good network design, will implement quality of service, QoS. Priority queuing has 4 queues. The highest priority queue is always emptied first. I'll zoom in so just we can see this. And the voice, obviously, voice and IP phones, it has the highest priority because you can wait a little longer for your file to transfer or your website to load, but you can't lose packets when you're making a phone call or video. Degradation can really make the video hard to see or the conversation hard to understand. So then we have SMTP, medium priority, instant messaging, normal priority, and FTP, low priority, to send traffic, again, because that file can, maybe it takes a minute to transfer instead of 30 seconds, who cares? Small network applications and protocols. So after you have set it up, your network still needs certain types of applications and protocols in order to work. The network is only as useful as the applications that are on it. There are 2 forms of software programs or processes that provide access to the network. Network applications, those are applications that implement application layer protocols and are able to communicate directly with the lower layers and the protocol stack. That's basically the actual, for example, the transport layer. That layer interacts between the application layer and the lower layers, preparing the data to transfer it out on the network. Application layer services, as you can see in the diagram, for applications that are not network aware, the programs that interface with the network and prepare the data for transfer. So email and file transfer and domain name services, they're not aware, or they don't actually, the application itself doesn't care about the network being ready to transmit the data. It's going to try to send the stream of data down the OSI model on its own, and then the lower layers, the network application layers, are going to handle that traffic and send it lower, and then down to the physical and out. Common protocols. Network protocols support the applications and services used by employees in a small network. These are the front-facing protocols that you should be aware of. Network administrators commonly require access to network services and servers. The 2 most common remote access solutions are Telnet and Secure Shell, to be able to remote into your equipment. Then there's Hypertext Transfer Protocol, HTTP, and the secure option, which are used between web clients and web servers. Simple Mail Transfer Protocol, SMTP, is used to send mail, email. Post Office Protocol and IMAP are used to receive email. File Transfer Protocol and the secure option, FTP, are used to download and upload files between a client and an FTP server. Dynamic Host Configuration Protocol, DHCP, is used by clients to acquire an IP configuration from a DHCP server. And then the domain name server resolves domain names to IP addresses. Now, a server could provide multiple network services, and that was what I gave you an example earlier, when you have multiple servers, that one could be an email FTP. Well, they can both be email FTP and SSH. So if one server goes down, the other one can kick in. These network protocols comprise the fundamental tool set of a network professional. And what we're talking about is processes on either end of a communication session types of messages, the syntax of messages, the meaning of informational fields, how messages are sent and the encrypted response, and the interaction with the lower layers. Many companies have established a policy of using secure versions of the protocols whenever possible. And you as a technician, you are going to build your toolbox, your tool set, to be able to understand the messages and the meaning of data that's transferred between computers. And you need to be able to troubleshoot, find the problem. Now they finished this section by talking about voice and video applications. Today, businesses are increasingly using IP telephony and streaming media to communicate with customers and business partners, as well as enabling their employees to work remotely. The network administrator must ensure the proper equipment is installed in the network and that the network devices are configured to ensure priority delivery. The factors that a small network administrator must consider when supporting real-time applications include the infrastructure. Does it have the capacity and the capability to support real-time applications? The equipment itself. The VoIP. VoIP is typically less expensive than IP telephony, but at a cost of quality and features. IP telephony, this employs dedicated servers for call, control, and signaling. And then real-time applications, that the network must support quality of service QoS mechanisms to minimize latency issues. Real-time transfer protocol RTP and real-time transfer control protocol RTCP are two protocols that support real-time applications. Scaling small businesses, SOHO, to larger networks. Growth is a natural process for many small businesses, and their networks must grow accordingly. Ideally, the network administrator has enough lead time to make intelligent decisions about growing the network in alignment with the actual growth of the company. Of course, this includes planning ahead of time. To scale a network, several elements are required. Network documentation, that's the physical and logical topology. Those are the opening documents that indicate what the current system is. And then you will finish by modifying network documentation to show the new configuration when you are done. Device inventory, it's a list of devices used or to comprise the network. Budgeting, how much money you got to spend. And then this actually could be done annually, should be done annually, probably will be done annually to always plan for the future and to spend money on the things that need to be taken care of immediately. Traffic analysis. Protocols, applications, and services and their respective traffic requirements should be documented, and we'll come back to that in a couple minutes. These elements are used to inform the decision-making process that accompanies the scaling of a small network. Protocol analysis. It is important to understand the type of traffic that is crossing the network as well as the current traffic flow. There are several network management tools that can be used for this purpose. To determine traffic flow patterns, it is important to do the following. Capture traffic during peak utilization times to get a good representation of the different traffic types. Perform the capture on different network segments and devices, as some traffic will be local to a particular segment. You can also look for bottlenecks with that type of search, different location, different networks, different equipment. Information gathered by the protocol analyzer is evaluated based on the source and destination of the traffic, as well as the type of traffic being sent. The analysis can be used to make decisions on how to manage the traffic more efficiently. They're going to come back and they're going to talk about keeping a record of all of these tests and doing the tests while the equipment is at current levels. You don't want to wait until there's a problem to do your testing, because then you will just see, you won't be able to see what the normal traffic is. Many operating systems provide built-in tools to display such network utilization information. These tools can be used to capture a snapshot of information such as the following: the operating system and operating system version, CPU utilization, RAM utilization, drive utilization, non-network applications, and network applications. Documenting snapshots for employees in a small network over a period of time is very useful in identifying evolving protocol requirements and associated traffic flows. You may be able to determine in advance when you may have a problem and modify or upgrade your equipment before that actually becomes a problem based on the trends that you see. Verifying connectivity. Whether your network is small and new, or you are scaling an existing network, you will always want to be able to verify that your components are properly connected to each other and the internet. The ping command, available on most operating systems, is the most effective way to quickly test layer 3 connectivity between source and destination IP address. The ping command uses the Internet Control Message Protocol, ICMP Echo, and ICMP type, that is ICMP type 8, and Echo Reply ICMP type 0 messages. I'll zoom in just to show you that they are sending an ICMP Echo message out. When it's received, you get an Echo reply indicating that PCA was able to communicate with PCB. Now, note, it does not troubleshoot anything in the middle. You're not getting any results telling you where it breaks down. If in the middle, if something broke down, you wouldn't know until you do the next test, which is, well, I guess it's on the next slide. We're going to get to traceroute and traceroute in a minute. Verifying connectivity with a ping continued. On a Windows 10 host, the ping command sends 4 consecutive ICMP echo messages and expects 4 consecutive ICMP echo replies from the destination. The iOS ping sends, the Cisco iOS ping, sends 5 ICMP echo messages and displays an indicator for each ICMP echo reply received. So if you get in the iOS, in the Cisco iOS, you get an exclamation point. That means that it was successful. The echo reply was received. It also validates a layer 3 connectivity between the source and the destination. If you get a period, that means that the time expired waiting for an echo reply message. This indicates a connectivity problem occurring somewhere along the lines. And then a capital letter U indicates that a router along the path responded with an ICMP type 3 destination unreachable error message. Possible reasons could include that the router does not know the direction to the destination network, the path, or it could not find the host on the destination network. Now, Cisco iOS has an extended mode of ping, and to get to this extended mode from privileged exec, you just type ping without a destination IP. Then you will be given several prompts to customize for the extended ping. Note that pressing enter accepts the default, so you can enter, and go through all the steps and just modify the one that you care about. So I'm going to zoom in for us to see a little closer. And you can see, for example, repeat count. So if you hit ping, you'd have to obviously put in an IP address and then how many times you want it to repeat. And then you can make changes and adjust. And these are actually taught at a higher level course, but you can learn more about them online if you want, or when you need to learn about that in extended ping. The ping command is useful to quickly determine if there is a layer 3 connectivity problem. However, it does not identify where the problem is located along the path. Traceroute on an iOS router can help locate layer 3 problems areas in a network. A trace returns a list of hops as the packet is routed through the network. The syntax of the trace command varies between operating systems. Notice here that if you're on a Windows computer, it is trace cert, and on a Cisco router or switch router, it is trace route. Now, note trace route, it's easy to remember. Routers have use trace route. If it's trace cert is not a route, so it has to be the host device. The following is a sample output of a trace cert command on a Windows 10 host computer. Note that when you, if for some reason the connection isn't made, you can actually break the trace cert and not wait till it ultimately errors out. The only successful response was, in this case, to the gateway on R1. A trace request to the next hop timed out as indicated by the asterisk, meaning that the next hop router did not respond or there is a failure in the network path. In this example, there appears to be a problem between R1 and R2. You're able to get to R1, but you're not able to get past it. The following sample outputs of trace route command. On the left, the trace validated that it could successfully reach PCB. On the right, the 10.1.1.10 host was not available. Notice the asterisks here, right? And the reply is timed out. Timeouts indicate a potential network problem. Use the Control-Shift-6 to interrupt the trace route in the iOS. Note, Windows implementation of traceroute, which is called tracecert because it's not a router, sends ICMP echo requests and listens for the echo replies. Cisco iOS and Linux use UDP with an invalid port number. The final destination will return an ICMP port unreachable message. Like the extended ping command, there is also an extended traceroute command. It allows the administrator to adjust parameters related to the command operation. The Windows tracecert command allows the input of several parameters through options in the command line. However, it is not guided like the extended traceroute iOS command. The following output displays the options available with the Windows tracecert. Remember, if you've used DOS from back in the day, or just go to the command window and try to see the options, you do tracecert /?, and that will give you the options that you have, and then you include those options when you want to do numerous things. The Cisco iOS extended traceroute option enables the user to create a special type of trace by adjusting parameters related to the command operation. Extended traceroute is entered in privileged exec mode by typing traceroute without a destination IP address. iOS will guide you through the command options by presenting a number of prompts related to the settings of all of the different parameters, just like we did earlier with ping. A couple of little differences here, but same idea. As you hit enter, it goes through each option. The network baseline. One of the most effective tools for monitoring and troubleshooting network performance is the establishment of a network baseline. One method to start a baseline is to copy and paste the results from an executed ping, trace, or other relevant commands to a text file. These text files can be time-stamped with the date and time saved into an archive folder for later retrieval and comparison. Among items to consider are error messages and the response times from host to host. Corporate networks should have an extensive baseline, more extensive than we can describe in the course. Professional-grade software tools are available for storing and maintaining this baseline information. You're going to do a lab to test network latency with ping and traceroute. And again, I believe in this lab, at least at one point, you're using your own PC. 17.5, host and iOS commands. Now, IP configuration on a Windows host. In Windows 10, you can access the IP address details from the Network and Sharing Center to quickly view the 4 important settings: the IP address, mask, router, and DNS. Or you can issue the ipconfig command at the command line of a Windows computer. Use the ipconfig/all command to view the MAC address, as well as a number of details regarding the layer 3 addressing of the device. If a host is configured as a DHCP client, the IP address configuration can be renewed using ipconfig/release and then ipconfig/renew. The DNS client services on a Windows PC also optimize the performance of DNS name resolution by performing previously resolved names in memory. The ipconfig/display DNS command displays all of the cached DNS entries on a Windows system. In this example, they show just the ipconfig and the IP address for both IPv4 and IPv6. You can verify IP settings using, when we're talking about Linux computers and a Linux interface, you can verify IP settings using the GUI on a Linux machine. It will differ depending on the Linux distro and the device interface. On the command line, use the if config, not ipconfig, that's for Windows computers, if, that's interface config on a Linux computer, to display the status of the current active interfaces and their IP configuration. The Linux IP address command is used to display addresses and their properties. It can also be used to add or delete IP addresses. Note, the output displayed may vary depending on the Linux distribution, and they just show the output of a ifconfig command. Then they go to Mac. They show what a Mac looks like. In the GUI of a Mac host, open Network Preferences Advanced to get the IP address information. Or you can go to the command line and do an ifconfig command, and that will verify the information IP configuration at the command line. Other useful Mac commands to verify the host IP settings include network setup space dash list network services and the network setup space dash get info commands, and then put in the network service you're looking for. The ARP command. The ARP command is executed from the Windows, Linux, or Mac command prompt. The command lists all devices currently in the ARP cache of the host. The ARP-A command displays the known IP addresses and MAC address bindings. The ARP cache only displays information from devices that have been recently accessed. Remember, I think the window's 200 seconds. I'm not positive about that. I should have looked it up before the presentation, but there is a time limit for Mac. For the ARP table to retain the ARP bindings. The cache can be cleared by using the netsh space interface space IP space delete ARP cache command in the event the network administrator wants to repopulate the cache with updated information. You may need administrative access on the host to be able to use that command. Now we've learned about these commands: the show run, running config, show interfaces, show IP interfaces, show ARP, show IP route, show protocol, show version. We've learned about these as we've moved through the course. You really need to know what each one of these does from heart. You should have all of these listed inside of your tech notebook for doing the labs, but by now you really need to not only know these exams, but you need to know which ones are the best. I'm taking some Cisco practice exams, and as I move through the practice exams, several of them have asked the question like, which is the best way to verify layer 3 information? And then they'll give you show IP interface and show IP route and show ARP and show protocols, and you've got to know between the four which one is the best. Of course, show IP route would be great if you want to know all the information in the routing table, and show IP interface is good if you want to know the information about a single interface. And then how does that compare to show interfaces? CDP provides the following information about each CDP neighbor device. It gives you the device identifiers, the configured host name of a switch, router, or other device. The address list, up to one network layer address for each protocol supported. Port identifier, the name of the local and remote port in the form of an ASCII character string, such as Ethernet 00. Capabilities list, whether a specific device is a layer 2 or layer 3 switch. Platform, the hardware platform of the device, and and the showed CDP details neighbors detail command reveals the IP address of the neighboring device. So let's look at that command and what we see. Here we have the show CDP neighbors command, and I love that it gives you the codes at the top so that you can easily understand what they are when you're looking at it below. So you are on S3, and your local interface is gigabit 001. It's set to hold time of 122. This is capability, S and I. S is it's a switch. I is it's capable, or it's running IGMP. It is a WFC. It's a 2960 switch, and it's connected on its fast Ethernet 0/5. Now, I want to correct myself here. You are on R3. You know where you are. So the device you're connecting to is S3. So you're connecting to S3 on your gigabit 01. On the other side, it's connected to this switch's interface, fast Ethernet 05. Just needed to correct myself there. And it's pretty obvious when you look at that. You're on R3 doing the command, duh, right? And so this switch has to be what you're connecting to. And one of the most frequently used commands is the show IP interface brief command. This command provides a more abbreviated output than the show IP interfaces command, which can be extensive. It provides a summary of the key information for all network interfaces, such as if the interface, like G000, what its IP address is, and whether it's up and up, or whether it's down and down, or if there's anything administratively down. And they show you what it looks like on a switch. It's similar. You're adding in the VLAN here as well, obviously. We have a video to watch. It is video 17.5.8 for those of you that are watching this video, this presentation on YouTube. You can see all of these videos in case the video of a video doesn't work. You can go to IT exam answers, and this has not only the exam answers, which you should not use in my class, but also all of the blank packet tracers, all of the completed packet tracers, but they're all labeled guessed. So as soon as you add your name, it erases everything that's there. It also has all the content and the videos, so you might want to make a note of that, itexamanswers.net. If you're in my NetAcad class, after the class is over, unfortunately, after about 90 days, actually 90 days after the class is over, it gets archived. So unfortunately, it's a new thing that Cisco is doing. So you can't go back and look at your Cisco 1 class when you're in Cisco 3 and you're preparing. So make sure but you can always go to this IT exam answers and get all sorts of exam questions that you can practice on and content that you can review. I'm going to go ahead and play this video here and let you listen.
In this demonstration, I'm using the term terminal emulation program to get to the console command line interface of a 4321 router. I'll press enter and then type enable, and then I'll use the show version command from within privilege exec mode to view information about the router. At the top of the show version command, I can see the Cisco iOS software version that is running on this router. This shows me that the router is running the universal K9 image, which provides all the basic Cisco iOS software features, including support for strong cryptography. It is the extended maintenance package, major release 16, minor release 6, and rebuild number 4. I can also see that the router has been up for 4 minutes. I'll press the spacebar to display more output. This tells me the name of the iOS image file and that it is located in boot flash memory. ISR 4300 refers to the hardware platform for which this image was built. You'll recall that I'm using a 4321 router. Again, here is the version for the iOS image file, and SPA means that the image has been digitally signed. The bin at the end of the file name refers to the file format. In this case, it is a binary file. Here we see the reason for the last reload. This indicates that I issued the reload command to restart the router. This information can be helpful when troubleshooting, especially if you have a router that crashes. Below is information regarding the cryptographic features of this router. I'll press the spacebar twice to display the rest of the output. Next, we have information on licensing. It is broken up into 2 categories, suite licensing and technology package licensing. First, let's examine technology package licensing information. This indicates that we have a permanent license for the IP-based K9 package, which is the default image feature set and the package and feature set that was specified when the router was ordered. It shows that it will continue to be available upon the next reboot. We currently do not have any other permanent or evaluation licenses installed. If we wanted to upgrade our iOS or install new features, it is a 3-step process. First, purchase the software package or feature and obtain a product activation key or PAC. Second, obtain a license using your PAC and the UDI of your device or unique device identifier. And then lastly, install the license. We could purchase a suite license that contains multiple features. If we did, that information would appear in this area. Next, we see that roughly 2 gigabytes of DRAM have been partitioned into main memory and shared memory. Main memory is reserved for the CPU to execute iOS software commands and also holds the running configuration and routing table, among other things. Shared memory is used to buffer data as it is transmitted or received on the network interfaces of the router. The contents of DRAM will be lost when the router is powered down. Next, we see the number and type of physical interfaces. This router has 2 gigabit Ethernet interfaces and 2 serial interfaces. Next, we have 32 megabytes of NVRAM, or non-volatile RAM, which is electronically erasable and reprogrammable. This is used to store the startup configuration file or saved configuration and the configuration register setting as shown at the bottom of this output. We'll get to that in a moment. The contents of NVRAM are retained when the device is powered down. Next, we see that the router has 4 gigabytes of physical memory. This is the total amount of DRAM, which includes the main and shared memory discussed above. Again, all contents are lost when powered down. Next, we have approximately 3 gigabytes of flash memory, used to store the Cisco iOS software image and other system files. Lastly, we can see the configuration register setting written in hexadecimal. This is the factory default setting which instructs the router to load the iOS image from flash and then load the configuration files stored in NVRAM. But what if you forgot your password and cannot access your router? You can change the default boot process by altering the configuration register setting so that the configuration file won't load from NVRAM on boot up. allowing you to access privileged exec mode without a password. You can see that the show version command gives us basic information about the router, including the iOS version, how long the router's been up, and how much memory and storage the router has. This information can be helpful during troubleshooting or when upgrading your iOS.
All right. Okay. And you're going to do a packet tracer where you are going to interpret show commands. I like the fact that you are not actually required to configure anything. You're just going to be analyzing the output of several show commands. Now troubleshooting. Now the 6-step troubleshooting methodology shown here is not something that should be new to you. This is the same thing that I teach in my hardware class. So you should be familiar with this. There are other methodologies, but this is as good as any to teach with. Step 1, you identify the problem. It's the first step in the troubleshooting process. Although tools can be used in this step, a conversation with the user is often very helpful. So in that step, you're talking to somebody that reported the problem and you're asking them, okay, how did this happen? When did this happen? And there's a lot of different things. Somebody tells you they came in, they were working on their computer and lightning hit outside in the parking lot and their computer stopped working. That will definitely help you to understand that it probably is related to power or power surge. And you get the idea. Trying to talk your way and ask questions to help identify where the problem came from will help you to get to step 2. That's to establish a theory of probable causes. After the problem is identified, for example, the computer won't load, try to establish a theory of the probable cause. Lightning strike, fried hard drive, or fried power supply. This step often yields more than a few probable causes of the problem. The next step is to test the theory to determine the cause. So based on the probable causes, test your theories to determine which one may have caused the problem. A technician may apply a quick fix to test and see if it solves the problem. A quick fix does not correct the problem. If it doesn't correct the problem, you might need to research the problem further to establish the exact cause. So I like to go back to my Navy days. I worked on computers back in the day that had hundreds of cards that all enclosed in drawers that could slide in and out of these Yuck 7 computers. Don't worry about what it is. But anyway, so Combat would call down and say, hey, the computer's not working right. Can you take a look at it? And we would have an error message on the screen indicating what the computer thought was wrong. If we're lucky, that's what happened. And it would say, change out this card, a specific card. And then all we did was change that drawer of 100 cards, let's say, with another drawer that we knew was good, and see if the problem moved over. If it moved over, great. Now we know we've narrowed it down to 100 cards, and the system can be brought back up again. Then we go troubleshoot that drawer of cards, and we even know which card to start with because the computer used to tell us which card to look at. Now, if it doesn't fix the problem, if you move it, it doesn't fix the problem. Well, now you've got to dig deeper. What else could be the problem if it isn't that 100 cards related? What else could create the problem? That's where you have to dig a little deeper and troubleshoot and use your experience and know-how of the system. Now, as you follow testing the probable causes with establishing a plan of action and implementing a solution. So after you've determined the exact cause of the problem, establish a plan of action to resolve the problem and then implement the solution. Then verify that it has corrected the problem. Verify full functionality and ultimately implement preventative measures to ensure whatever the problem was doesn't happen again. For my example of a lightning strike, maybe you add a surge suppressor in the line to help to protect your equipment. Finally, you have to document your findings, actions, and outcomes. It's the final step of the troubleshooting process. you have to document your findings, actions, and outcomes so that in the future you can reference back to them. Hey, what was this problem? What was caused it the last time? Oh yeah, I remember. And then you can go back, or if it's not even you, somebody else can, let's say you've moved on to another company, another job, somebody else can, you or somebody else could see a trend where this problem happens every year. Maybe you need to reach out to the manufacturer and indicate that they need to do some research of why their product is dying every year. Or maybe you have to plan ahead of time, knowing that it's going to die. You need to make sure that you have spares on hand to correct that problem. Resolve or escalate. In some situations, it may not be possible to resolve the problem immediately. A problem should be escalated when it requires a manager decision, some specific expertise, or a network access level unavailable to the troubleshooting technician. A company policy should clearly state when and how a technician should escalate a problem. The debug command. The iOS debug command allows the administrator to display OS process, protocol, mechanisms, and event messages in real time for analysis. All debug commands are entered in privileged exec mode. The Cisco iOS allows for narrowing of the output of debug to include only the relevant features or subfeatures. Use debug commands only to troubleshoot specific problems. You wouldn't want to let it run continuously just in case, for example. To list a brief description of all debugging command options, use the debug space ? Command in privilege exec mode, just like we get help on all of the other commands in Cisco. To turn off a specific debug feature, add the no in front of the debug command, just like everything else. But there's another way to do this, to turn off a debug, and you can enter the undebug form of the command in privileged exec mode. Now, the reason why they teach you undebug is because then they teach you that you can turn off all of the active debug commands at once by typing undebug all command. Otherwise, you have to go through no debug for multiple debugs that you have enabled. You can just use undebug all. Be cautious about using some debug commands as they generate a substantial amount of output and use a large portion of system resources. The router could get so busy displaying debug messages that it would not have enough processing power to perform its networking features or even listen to the commands for turning off debug. And here they show you the debug command. First of all, they ran telnet to be able to get some commands in the system. Then they ran debug IP ICMP, and it says that ICMP packet debugging is on, and then they ping something to be able to get some output, and you are able to see some error messages. Here we go. Here's some error messages. So we go, in this case, terminal monitor, that allows your error messages to show up on your terminal instead of being sent someplace. And then they did that ping again, and notice the echo reply received to the ping commands 5 times. And then to turn it off, no debug IP ICMP. Troubleshooting scenarios. So interconnecting Ethernet interfaces must operate in the same duplex mode for best communication performance and to avoid inefficiency and latency on the link. The Ethernet auto negotiation feature facilitates configuration, minimizing problems and maximizing links performance between two interconnecting Ethernet links. The connected devices first announce their supported capabilities, and then choose the highest performance mode supported by both ends. If one of the two connected devices is operating in full duplex and the other is in half duplex, a duplex mismatch occurs. While data communication will occur through a link with a duplex mismatch, link performance will be very poor. Duplex mismatches are typically caused by misconfigured interfaces or, in rare instances, by failed auto-negotiation. Duplex mismatches may be difficult to troubleshoot as the communication between devices still occurs, just degraded. Two common causes of incorrect IP. Okay, so IP addressing issues that you might run into. There's two common causes of incorrect IP address assignments, and that is you might manually make mistakes, or you could have DHCP related issues. Network administrators often have to manually assign IP addresses to devices such as servers and routers. If a mistake is made during the assignment, then communication issues with the device will likely not occur. Oh, the communication issue, you're going to have communication issues and the device will not communicate. On an iOS device, use the show IP interface or show IP interface brief commands to verify the IPv4 interfaces are assigned to the network interfaces, the correct numbers are assigned. For example, using the show IP interface brief command, as shown, would validate the interface status of R1. And you can see here you have two gigabit Ethernet connections. They've both been established IP addresses, and they were both up and up. You've got a couple that have been unassigned, and you have a gigabit Ethernet 0 address that is administratively down. IP address issues on end devices. On Windows-based machines, when the device cannot contact a DHCP server, Windows will automatically assign its own IP address belonging to the 169.254.0.0.16 range. This feature is called Automatic Private IP Addressing, a PIPA. You've seen that address before, and it's important for you to remember 169.254.0.0 because in testing, that address or an address in that range is often used as a distractor. Now, a computer with an APIPA address is not able to communicate with other devices in the network because those devices will not likely be along to the 169.254 address network. Now, what I want to add to that is if you would be able to communicate with other devices that have an APIPA address because they would be in that 192.254 network, but you would not be able to communicate outside of the network. Other operating systems such as Linux and OS X do not have a PIPA or don't use it. If the device is unable to communicate with DHCP server, then the server cannot assign an IPv4 address to the specific network and the device will not be able to communicate. To verify the IP addresses associated to a Windows-based computer, use the ipconfig command to see the IP, and then you just make sure that the address that's assigned is correct. Default gateway issues. The default gateway for an end device is the closest networking device, belonging to the same network as the end device, that can forward traffic to other networks. If a device has an incorrect or non-existent default gateway address, it will not be able to communicate with devices in remote networks. Similar to IPv4 addressing issues, default gateway problems can be related to misconfiguration. In the case of manual assignment or DHC problems if automatic assignment is in use. So you can just go in and type in the default gateway incorrectly, or DHCP could automatically assign the wrong address, or no address at all. To verify the default gateway on Windows-based computers, use the ipconfig command. On the router or on a router, use the show IP route. That'll show you your routing table command to list the routing table and verify that the default gateway, known as a default route, has been sent. It'll be at the bottom of the routing table with an asterisk if it's IPv4. This route is used when the destination address of the packet does not match any routes above in the routing table. It is common for users to mistakenly relate the operation of an internet link to the availability of DNS when you're troubleshooting DNS issues. DNS server addresses can manually or automatically be assigned via DHCP. Although it is common for companies and organizations to manage their own DNS servers, any reachable DNS server can be used to resolve names. So you may have several DNS servers reachable, and and you're not always certain which the host will choose. Cisco offers OpenDNS, which provides secure DNS services by filtering phishing in some malware sites. OpenDNS addresses are 208.67.222.222 and 208.67.220.220. Advanced features such as web contact filtering and security are available to families and businesses. Use the ipconfig/all as shown earlier in this presentation to verify which DNS server is in use by the Windows computer. The nslookup command is another useful DNS troubleshooting tool for PCs. With nslookup, a user can manually place DNS queries and analyze the DNS response. You are going to do a lab troubleshooting technical issues and a packet tracer as well. And then you're going to do 2 labs, one for designing a small business, and then you're going to do a lab for designing and building a small network, a packet tracer for the skills integration that basically ties everything you've learned all semester into one. And if you can do this without looking up answers, then you're probably perfectly fine when it comes to completing the final exam, the final practical, because it includes the practical includes many of these challenges. And then you're going to do a troubleshooting challenge, probably one of the hardest assignments you'll get all semester, but it's perfect because it's the last one you've got to do. And at that point, once you're done with this, you are good to go. All right. So that is it for our last presentation. That is module 17. It has been a pleasure these 15 weeks and 17 modules to be your teacher. If you have any questions about this presentation, hang out and I'll answer those questions in just a couple minutes. If you're watching this as a recording in NetAcad, ask in the help discussion forums. And if you are asking in YouTube, please ask your questions down below in the comments. Also, please give me thumbs up and follow so you get future announcements when I release future videos. I've also created on that note, I've also created all of the Cisco 2 videos, and they should be posted already, at least they will within a day or two of me posting this in the summer of 2021. You should see all of the Cisco 1 and all of the Cisco 2 videos. I'm planning on creating the Cisco 3 videos over the next few weeks, and I will post those as well. So if you need any training in Cisco 1, 2, and 3, watch for my videos. Hopefully they're helpful for you. Again, it's been my pleasure helping you learn Cisco. You can make comments down below. If there's anything I can do to improve my presentation, I appreciate those comments. And if you have any questions, go ahead and comment. And of course, anybody can answer the questions you have. I love that community that can be built in the comment section between Cisco learners. All right, that's it for me. I'm Don Lafond, Professor Don. And again, it's been my pleasure. Enjoy your venture into Cisco, and good luck passing CCNA once you get to that point. All right. See you later.